Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to calculate the amount of chlorine gas that's produced when you're given the amounts of reactants and you're given the balanced equation. So let's get into this. So in this problem we're given if a 62.6 gram sample that is 98.5% K2Cr2O7 by mass is allowed to react with 325 milliliters of HCl aqueous with a density of 1.15 grams per milliliter and 30.1% HCl by mass, how many grams of Cl2 gas will be produced? And here they're giving us the balanced equation. So one of these K2Cr2 or potassium dichromate is going to react with 6 moles of HCl to produce your potassium oxide, your chromium oxide or chromium 3 oxide, and water and Cl2 gas or chlorine gas. So what do we do? How do we do this problem? Well, the first thing we need to know is what are they giving us, right? And so they're telling us if a 62.6 gram sample that is uh, K2Cr2O7 or potassium dichromate by mass is allowed to react with 325 milliliters of HCl. So they're giving us an amount of one reactant that's going to react with another amount of a different reactant, right? So this is a dead giveaway that you've got a limiting reactant problem. How do I know that? So anytime they give you a reaction and they give you the amounts of both reactants, and they're saying, hey, these two amounts, these amounts of these reactants are mixing together and they're reacting, and then they ask you, well, how much product is formed? It's a limiting reagent problem. You have to figure out which reactant is going to run out first, because that's going to control the amount of product that's able to be formed. And so they're giving us 62.6 grams of one substance, and they're giving us 325 milliliters of another substance. So which one is going to run out first? That's what we have to decide. We can't just pick and go. Okay, so that's really important to keep in mind. So this is a limiting reaction problem. There's a couple, maybe two or three different ways of going about solving this. One way would be to, well, you got to figure out what the limiting reagent is first, right? So one way is to convert one amount of one reactant into the amount of the other reactant that's required to react completely with the amount of the one reactant you're given. And then just compare, right? Do I have the amount of the other reactant needed to react completely, or do I have more than enough? Do I have not enough or more than enough? And then you can figure out from comparing which one's going to be the limiting reagent. So that's one way to do it, because once you find out what the limiting reagent is, then you start your conversions, your stoichiometry, starting with the reactant, that's the limiting reagent, and then you convert that to find the amount of product formed from that substance. Okay, so that's one way to do it. The way I'm going to do it is what I think is more straightforward, but that's just me, is to take each of the substances that you're given, each of the amounts, and convert each of those, each amount of reactant into the amount of product that it could form if it was to react completely, right? And then compare the amounts. If one reactant gives you less amount than another, then you go with the reactant that gives you less, because that means the reactant that gives you less is the one that's going to run out first and is going to control or limit how much product is going to form. Because once you run out of a reactant, the reaction stops, right? So let's go ahead and do it that way. So I'm going to take the 62.6 gram sample. So 62.6 gram of the K2 sample, the K2Cr2O7 sample. So I'm going to say K2Cr2O7, and I'm going to say SAMP for sample, because it's not pure K2Cr2O7. It's not pure potassium dichromate. It's just a sample. It's 98.5% potassium dichromate. So we need to convert this into the amount of Cl2. So what they gave us is 98.5% of our sample is actual potassium dichromate. So remember, if you're given a percentage, it's a conversion factor. You can use it as a conversion factor. So why? Because a percentage means out of 100. So in this case, they're saying that out of the sample here, this given sample, 98.5% of it is actually potassium dichromate. The other percent, the rest of it is whatever it is. It's not potassium dichromate. So if we understand that a percent is out of 100, that's telling us that out of 100 grams of our sample, 98.5 grams is going to be actual potassium chromate. And we can use that as a conversion factor. So what I'm going to do is I'm going to put 100 grams of our K2Cr2O7 sample. Oops. SAMP for sample. And then out of 100 grams, we're told that 98.5 grams is actually going to be K2Cr2O7. So now the grams of the sample cancel out. Now we actually have grams of the potassium dichromate. Okay, now that we have grams of potassium dichromate, now we can convert that to moles. We need to convert it to moles because we need to get to chlorine. And we can't get to chlorine unless we can use a mole ratio. So we could use a mole ratio between this and this, but we can't do that unless we have moles. So we need to convert to moles, and we're going to do that by using the molar mass. And we need to calculate the molar mass of the sample, and it's 294,181. So 294,181 grams of our potassium dichromate. And on the top, we're going to have 1 mole of our potassium dichromate. And so now grams cancels out. Now that we have moles, now we can use the mole ratio. 1 mole of the potassium dichromate will give us 3 moles of the chlorine. So that's going to be our next conversion. So on the bottom, we're going to have 1 mole of the potassium dichromate. And then on top, we're going to have 3 moles of the chlorine. So moles of the potassium dichromate cancel out. Now we have moles of chlorine, but they're asking for grams. So now we're going to use the molar mass of chlorine to convert moles into grams. And we looked that up, and the molar mass is 70.9. So 70.9 grams of Cl2 on top, 1 mole of Cl2 on the bottom. Moles of Cl2 cancel out. Now I have grams. So now all I need to do is multiply across the top, divide by what's on the bottom, and I'll get my amount of chlorine gas that would be produced from this amount of my sample. And so when I calculate that, I get 44.6 grams of Cl2. So this is going to be equal to 46. Did I say 46? 44.6. So 44.6 grams of Cl2. Now, so this is the number of grams that would be produced from this amount of our sample if this reacts completely. But the only way that this reacts completely is if it's the limiting reagent. But we don't know that yet. We need to do the same calculations with the HCl and then compare the amount of product from each. So then I'm going to start with HCl. So how much? We have 325 milliliters of HCl. So this time we're going to start with 325 milliliters of HCl. And they told us that it has a density of 1.15 grams per milliliter. So we got a volume here, but we need mass, right? Because we need to get to grams of the chlorine. Anytime you're given one substance and they want you to convert to a different substance, then you got to use the mole ratio, which means that in order to get to moles, we need to get to mass, so we could use the mole ratio, the molar mass. But we got volume here. But it's a great thing that they gave us the density, because the density is a relation between grams and milliliters, mass and volume. So we're going to use that to convert. So anytime they give you a density, that's a useful conversion factor. So here I have milliliters of HCl on the top. I'm going to put milliliters on the bottom. So I'm going to have 1 milliliter of HCl on the bottom and 1.15 grams of HCl on top. So now the milliliters cancel out. Now I have mass in grams, but this is the mass of my HCl solution, right? Not the grams of pure HCl. So it's really important to remember that and pay attention to what you are calculating and what substance you're given. So this is the solution, right? So if I write that down, solution, that will specify what we're talking about. So, that would be yeah, you're right. So grams of the solution, okay? But we want grams of the HCl in the solution, right? So that's why they gave us this piece of information. So our solution is actually 30.1% HCl by mass. So now that we have the mass unit in grams, we can use that conversion. We can use the percentage as a conversion. And again, percentage is out of 100. So what this percentage is telling us, 30.1%, is that out of 100 grams of the solution, the HCl solution, only 30.1 grams of it is actual HCl. The other grams is water, probably, right? So we want the mass of the HCl. So we're going to use that. We're going to use that percentage as a conversion factor. So out of 100 grams of solution, we're going to have 100 grams of HCl solution on the bottom. And out of 100 grams, 30.1 grams is actual HCl. So grams of the HCl solution cancel out. Now I have grams of HCl, the actual HCl that's reacting in this reaction. So now that I have grams of HCl, now I can use the molar mass of HCl to convert to moles. Why moles? Because again, I want to use the mole ratio between HCl and chlorine so I can convert to chlorine. So what is the mass of HCl, you ask? Let me tell you. It's 36.45.8. So 36 So 36.458 grams of HCl on the bottom and 1 mole of HCl on top. So now grams of HCl cancel out. Now I have moles. Now I can use the mole ratio. So I know that 6 moles of HCl is going to give me 3 moles of Cl2. So there's my mole ratio. So I'm going to put 6 moles of HCl on the bottom, 3 moles of Cl2 on top. Moles of HCl cancel out. Now I have moles of Cl2. Now I can use the molar mass of Cl2 to calculate grams. So I'm going to use the same molar mass here. And so again, that's going to be 1 mole of Cl2 on the bottom and 70.9 grams of Cl2 on top. So moles of Cl2 cancel out. Now I have grams of Cl2. So now all I need to do is, again, multiply across the top, divide by what's on the bottom, and I get my answer. And when I do that, I get 109.4. So 109.4 grams of Cl2. Now, I want you to look at something. So if the 325 milliliters of HCl solution that I have reacts completely, that would give me 109.4 grams of chlorine gas. If the 62.6 grams of my potassium dichromate reacts completely, then the maximum amount that I can get from that amount of this sample is 44.6 grams of chlorine. So this is the maximum amount that I can get from this amount of my K2Cr2O7 sample, my potassium dichromate sample. This is the maximum amount that I can get from my sample of my 325 milliliters of my HCl sample. So which one is the limiting reagent? The limiting reagent is the one that produces less. So this is the maximum that I can get from this amount. So that means that this is my limiting reagent. So this is my, limiting reagent. Why? Because it gives me the lesser amount of chlorine. This is the maximum amount that I can get from that amount. I can't get any more chlorine from this than this, right? So therefore, I can't get this amount. So therefore, this is the amount of chlorine that is formed. And so that, ladies and gentlemen, is the answer to this problem. And I hope you enjoyed this video. If this video helped you, if you learned a lot from this video, if I entertained you in any way, then please, by all means, like the video, share the video. Hit that like button over here somewhere. Over here, I think. Please support the channel, subscribe to the channel, hit that notification bell. When you do, make sure that you click that notification bell. And when you do that, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question about or a problem you need help with, or if you have a topic you want me to cover, I would love to do that for you. Thanks for joining me and have a great day.